All right, college algebra students, this is Dr. Demery. We're going to go ahead and do a review of Chapter 2 test, so that way you're prepared for the test that's going to come up. So I'm going to hand select certain questions. I'm not going to do every single one of these questions, but focus questions that may, in fact, give you exactly what you need. So pay attention to the ones that I go over most. Your objective is to try to complete the rest of them in line to what I'm going over. So I'm going to cover question number 2. Now, question number 2 says identify the x and y intercepts. Now, x and y intercepts are very easy to identify. It's where do they cross over the x-axis, which is obviously the horizontal axis, and where does it cross over the y-axis, which is the vertical axis. Now, in the x-axis, it's crossing over the -5, so we would put -5 for that, as well as -1. So those would be the two answers that we're looking for there, -5 and -1. Now, for the y-intercept, it's crossing over. Now, if you can't see it, you can always blow it up, all right? And you can see that it's clearly going over 5, all right? Now, 5 is the answer that we're looking for that. We just close that out, and we would answer the 5 for that. Okay, that should be really easy for you to identify and answer. All right, now let's take a look at question number 3. Now, this is an absolute value because we know that because of this right here. All right, now the thing that's really interesting is here is once you know how to use your graphing calculator, this should be really simple. All right, and I would encourage you to, rather than busting your hump trying to figure out how to, or not that you need to figure it out, it's not that hard. All you do is put a -3 in. The absolute value of -3 is 3. 3 times -4 is -12. -12 plus 4 is -8. So you get the answer of -8, and that's it. Okay, but all that work being said and done, all you got to do is hit y equals, hit in -4, absolute value found under math, num, ABS. And then we put in x and get out of it, plus 4, enter. Now what's great about this is you hit second graph, and it gives you the values of input for every single, or for every single input, it gives you the output that we need. So here are the answers: -8, -4, 0, and so on and so forth. So it would, those are the answers you would go ahead and plug in. All right, they exactly aligned to what's here in the calculator, so we don't have to sit there and sweat the small stuff kind of thing. Now, if you want to take a look at what the graph looks like, all you have to do is hit graph, and we can pick the right graph that goes along with it. Now, we want to be careful with what we select, and remembering that when we have -1 and then we have 1, it's 0, 0. So when we're going to go ahead and look at this, we have to be careful again. We will go ahead and, excuse me, not do that, but we zoom in and we see at the value of input, -1, -1, it's not 0. Okay, -1 and 1 aren't 0, so that's going to be a throwaway. So we want to come here and look at this one, and we would see that at -1, 1, they are both zeros. So that's the answer we're looking for. All right, so you'd have your answer. All right, now I'm going to go ahead and show the answer, which is in fact what we just selected, which is this one. Okay, so that would be your number 2, the second question we go over. Let's go ahead and look at number 6. Now, including a sales tax, a hotel charges $194.93. It says find the hotel's nightly rate before taxes is included. Round the solution to the nearest cent. So now what we're going to do is come in here, and we're just going to simply take the value of 194.93 and we're going to divide it by 1.03. That is 103% of the value of, the item that we're, the value of the hotel charge. Because this charge of 194.93 is the cost after the sales tax has been applied. So by dividing it by 103, you'll get the cost before that sales tax was added. So the answer we're looking for, rounded off to the nearest cent, would be 189.25. And see, now look at the answer, 189.25. Easy as that. Not really complicated. Number 11. Now we can't use our calculators for this one. We need to go ahead and perform the indicated operation. So when we are looking at that, basically what we're trying to do is we're trying to eliminate the I being in the denominator. It's called rationalizing the denominator. So we're going to go ahead and do is use what's called a complex conjugate. And that is just taking and switching the sign, all right, for this, which is in the denominator. Because what happens, it's like the foiling method of the difference of two squares. The O and I in FOIL go away. So all you have to do is multiply this times this, and then multiply this times this, but remembering that negative times a positive is negative, and that's -1 times +1. And then we have I times I, which is I squared, and I squared is equal to -1. Therefore, negative of a negative makes it a +1. And you notice how now we do not have any more i's involved. That's important. Now we do the same process, but this time, because they're not conjugates of each other, we'd have to FOIL. So -1 times 1 is -1. -1 times I is -I. And then -7 times 1, that's -7i, is -7i's. And then -7i times +I is -7i squared, which then becomes +7. Now, -1 added to +7 equals 6. And then you have 1 plus 1 is 2. Oh, by the way, let's get the i's taken care of. I plus, -I plus -7i's gives us -8i's. And then we have 2, but 2 goes into both of these. Like I look at it as a triangle. Therefore, I can reduce it down to 3. 2 goes into 6 3 times, and 2 goes into 8 -4 times, and 2 goes into itself 1 time. And therefore, I don't need to put it over 1. Here is my answer. All right, so let's take a look at the answer. And it's in fact what we came up with. All right, so there's a structure and approach to how you complete these. Please yield to what I just did. Number 13. It says now solve the quadratic equation by factoring. Enter solutions as comma separated list. All right, now so what we're going to do is bring everything over to the right side of the, say right, but I meant left side of the equation. So bring on over the +8 becomes now -8. And then I have the following. Now, when we have this, I call this a complex trinomial. Now, the reason why is because it has a leading coefficient. Anytime it has a leading coefficient, it makes it more complicated than if it didn't have that leading coefficient. So why I call it complex. So way to do that, it's the AC method, but I'm going to do what's called AC / the bottoms up methodology. That's the approach to take to complete factoring when you have a leading coefficient. So 3 times negative 8 is negative 24. And put negative 2 on the bottom. Now, what two numbers multiply together to create negative 24 that when added together gives you negative 2? So you have negative 6, all right, times positive 4 gives you negative 24 that adds up to negative 2. Circle these if you will, or if you wish, and then take those circled numbers and place them above the leading coefficient. Now reduce your fractions. Well, this one is negative 2 over 1. This one doesn't reduce, so it remains. And there's reasons for why I'm doing what I'm doing. Now I'm going to go ahead and do what's called bottoms up. Take the bottom and bring it up as the leading coefficient. So I have 1x minus 2, because it was negative, put that instead of parentheses, and then bring up the 3x and put positive 4 because it's a positive 4, right? And this is the factored form. But now we're solving this. So what we're doing is we're setting each factor equal to 0. So setting this equal to 0, we get x equals positive 2. Setting this equal to 0, we get x equals negative 4/3. Now, if you kind of look at this, if you do it right, the solution is just the opposite of what we came up with here. All right, take note of that. I mean, that's kind of an interesting strategy then, right? When you're solving it. So here we have, you just take the opposite of this, the opposite of that, and you have your answers. All right, so now we go ahead and answer it, which is going to be exactly what I came up with. All right, that's called the bottoms up method, mixed with the AC method. Why the AC method? Because this is A and this is C. So A times C, that yields B, and added together. So multiply together, create AC, two factors we're looking for, that adds up to B. Put those on top of the leading coefficient, reduce your fractions, and then bottoms up. It's so simple, okay? Here we have this. Now, when dealing with this one, okay, we want to kill fractions. We don't like fractions. Now, there are multiple strategies you can use to find out what the LCD is. What I'll do is here is I'm going to purposely select ones that won't work, but I'm going to multiply 7 times 3 and see if 12 can go into it. And I know it can't, by the way. All right, so it doesn't work. Now, so we do 7 times 12 and divide that by 3. And it looks like it works. It's at 84. Just to see that whether or not 3 times 12 equals 36, and we know that 7 can't go into 36. I'm not even going to try. Okay. So the answer that we're looking for the LCD is 84. So what we're going to do is we're going to go ahead and multiply both right side and left side by 84. Once I've done that, all right, we can see here that 7 goes into 84 12 times. So I have 12. And then we know that 3 goes into 84, and we've already determined it goes into it 28 times. So 28 times 10. And then 12 goes into 84 7 times. Therefore, we put 7 open parentheses, C plus 8. Okay. Now we have no more fractions. We're going to do the distributive property. All right. We have that. And now we're going to go ahead and combine like terms. Now, we can go ahead and see we have 7 C's. So we're going to go ahead and subtract 7 from both sides, get 5C. And then obviously we're going to bring the 280 together and subtract, well, the 280 with the 56 and then subtract 120. Now, we don't have to become like, oh my God, I have to do it all in my head. All I got to do is take 280 plus 56, hit enter, and then subtract the 120. And then we're going to go ahead and get 216. All right, and then we're going to divide both sides by 5. All right, so C is equal to that. Now let's take a look at what the answer is. All right, and we can see that it aligns exactly to what we came up with. The 216 over 5. All right, not too complicated. Solve the equation if multiple solutions exist and the solutions using a common separated list. So let's take a look at this one. So we have 9d squared negative 7. And so we know we're adding 7, so let's simply take the 893, add 7 to it, and then divide it by negative 9. And you get this so far. Now we need to take the square root of both sides. All right, we're going to put plus or minus here. Now, when we do that, we're taking the square root of a negative value. So we need I involved. So this is going to be plus or minus, all right, and then it's going to be 10 because square root of 100 is 10, I. Now, we have to enter it as comma separated list because first of all, they don't have a plus or minus sign anywhere here. So we're going to just, I always tend to put the positive first. So I'm going to put just 10I and then comma and then negative 10I. All right, and that'll be the same answer that they came up with. And you can see, get the right answer. All right, same answer. All right. Now, it says to use the quadratic formula. It's probably suggesting this because it would be the best approach to, getting the best, the answer. So you got to recall that x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You're going to have to recall that. You don't allow notes on the test. So now it's just a matter of plugging it in. It's all set up in A, B, C. We already know all the values. So we're going to take the opposite of 6 is going to be positive 6. That's negative 6. That is. Plus or minus b squared, which is negative 6 times negative 6 is 36. And then it's negative 4 times 9 times 79. And a negative 4 times a negative 79 is going to give us a positive value. Therefore, we do not need to worry about numbers, or the signs, I should say. But we're going to just make sure that we don't mess up our calculations. So 79 times 4 times 9. and we're going to get positive. And then we're going to get 2 times 9 is 18. Okay. Now, if we take this value and we add 36 to it, we're going to get this. Now, if we look at that, okay, we could try to go ahead and see if we could take the square root of it. And it doesn't work. Okay. Because it doesn't work, we want to try to pull out perfect squares if we can. All right. So now we can't find 100 in there. I mean, that's not possible. But let's go ahead and try to do just simple math. Let's go ahead and take that and divide it by 36 and see what happens. All right. 36 times 80 is that value. So just because I want to go ahead, and I know 80 could be broken down more, but I'm going to go ahead and take and break it down a little bit, because I know for a fact that 36 is a perfect square, because 6 times 6 is 36. Now we're going to go ahead and multiply that against 80. All right. So the thing is that 80 can be broken down further, though. All right. You could divide 80 by 4, for example. So if we just take 80 and divide it by 4, we get 20. But wait a second. 20 is there's another 4 in there. So 80 divided by 16 comes out to 5. So what we're going to do is just break this up even further, and we're going to do that. 36 times 16 times 5. Now, had we done this originally, we probably would have done this taking 3, what was it? The 280, 2880, and divided it by 5, and came up with 576, and you could take the square root of that. But we didn't know that. Who cares? The way we found it was no problem, because now that we did it the way we did, all we're doing is going ahead and pulling that out as now 6 times 4, radical 5. See, I don't know why people get so bent about radicals. I mean, as long as you take your time and find your perfect squares, it's not that big of a deal. So now we're looking at this as 4 times 6 is 24. And we know that 6 can go into all these. 6 goes into this 1 time, 6 goes into this 4 times, and 6 goes into this 3 times. So our official final resolved answer is 1 plus or minus 4 radical 5 all over 3. And let's see what they come up with the answer. Well, they have the plus or minus, so they're going to separate the value. So it's 1 minus 4 radical 5 over 3. And then it's 1 plus 4 radical 5 over 3. So the exact same answer we came up with here. Now that was not a picnic. That was pretty tough. All right. You got to keep calm and just do what you need to do to simplify it. Now it says complete this by using the completing the square method. Now let me show you how that works. All right, first of all, everything here is divisible by 3. You'd have to agree. So what we're going to do is divide everything by 3. And get the following. All right. Now that I have done that, okay, I'm going to complete the square now. Completing the square is half of b squared. So half of -4 squared, and that half of -4 is -2 squared, and that would give us 4. Now, what happens when we do that is we add 4 to this side and add 4 to this side. But by adding the 4 to both sides, it becomes a perfect square, which whatever you take half of the middle term, the -4 that is, half of that right here is what you put in a binomial. And then you go ahead and do 5 plus 4 is 9. That's how that works. And then you go ahead and take the square root of both sides. That's plus or minus. And we get this. And then we go ahead and make two problems. U equals 2 plus 3 and 2 minus 3, or simply 5 plus -1. Okay. Now, some of you probably would have thought to yourself, why didn't I just go ahead and factor that by other strategies? And the answer is, I agree. But it asked us to complete the square, so I did. All right? So I did. Question number 22. I'm going to go ahead and bring over the -22 and make it become +22 equals 0. All right, now I factor, or I group the first two terms together and the second two terms together. By grouping this together, I'm going to get x squared, x minus 11. And then I'm going to factor out a -2, and I'm going to get -2 plus 11 over here. Excuse me, that's a negative. I was looking at something else while I was writing. All right, so then that's negative because I'm factoring a negative. All right, and then we're going to go ahead and see that these are the same. And then we're going to bring these together. And it says solve the following polynomial. So our answer is going to be plus or minus square root of 2, as well as positive 11. Now, why did I put plus or minus square root of 2? Is because obviously I'm going to bring it over to the other side, make it become positive, and then I'm going to take the square root of both sides in order to kill the square for this x. So when I do the square root property, I'll always put plus or minus sign. That's pretty straightforward. So let's take a look at the answer. Is what we came up with. Okay. Now, U-substitution. U-substitution allows us to handle where we have appearances of a quadratic, but they look kind of hidden. But if we think about it, we let U equal the middle term, by the way. And then by understanding that if we squared U and we squared this U right here, we would get the same term as what's in the front. So therefore, you can represent now this as a quadratic. And by the way, notice I brought the -32 over, made it become positive. Now, what two numbers multiply together to create 32? That add up to -12. Now, what do you know about 32? So 8 times 4 is 32, right? So we're going to go ahead and put -8 and then -4. And when you add that together, you get -12. Okay. Now we're going to go ahead and say that u equals 8 and u equals 4. But wait a second, we don't want to deal with u. We want to deal with what u represents, and u represents with m to the third, or 1/3 power. So we resubstitute back in. And we get the cubic root. I disregard that. No, we don't. We take the 3rd power of. We're going to raise it to the 3rd power. Apologize. And then we have the same idea going on with the 4. We're going to take the cubic power of both sides. Now, if I'm not mistaken, this is 512. And this is going to be 64. And if I don't trust myself, I can go ahead and do 8 to the 3rd power and get 512. All right. And then 4 to the 3rd power and get 64. All right. So you can use your calculators. I just happen to know what they were. Right. I've been doing math for a while. So our answers are what I've just given you. 64 and the 512. $29. All right, now what we want to do is we want to isolate the radical so we can go ahead and solve for it, right? So we're going to go ahead and bring this over to the other side. And then divide both sides by 2. Now, once we've done that, all right, we need to get rid of this radical. So what we have to do is we need to raise it to the 2nd power to both sides. All right, this will go away, leaving us with x. And then we're going to go ahead and get positive 1/4 x squared. And then we're going to go ahead and multiply them together and then double it. So multiplying them together, we're going to get positive 1 times 5 is 5, and then 2 times 2 is 4, and then doubling it, it's going to go ahead and give us 5 halves. And then multiplying it together. Okay. Now, if we want to go ahead and have the same denominator for everything, we could do that. But now, what we don't want right now, since we've gone ahead and gone through the trouble of this, we want to kill the fraction now. Okay. So we're going to multiply everything by 4. So we're going to get 4x and then 32 x squared, and then 2 times 5 is 10, and then plus 25. All right. Yeah, looks good. All right, now we're going to go ahead and subtract 4 from both sides and subtract 32 from both sides. I apologize, I was falling off the page. Okay. Again, we go ahead and square it. It gives us this. Multiply everything by 4, and you get this. So I'm sorry if I didn't realize I was off the screen until I looked up at the for the screen. I'm like, I'm completely off. Sorry about that again. All right, so now let's go ahead and move it over. All right, so if we subtract 32 from 25, we will get -7 equals 0. All right, so now what two numbers multiply together create -7 to add up to 6? So that would mean and then of course our answers would be x equals -7 and x equals +1. Now, the thing that we want to be careful with, right, is that when we got to a point where this was isolated, okay, we don't want to have it where we're going to get a negative value, okay? So when we take -7 times this, all right, that's going to give us a +7/2. And when we add it together, that's going to give us a positive value. So this one works, whereas this one doesn't. So we have to throw this one out. This isn't going to work. And you can test it, okay? You can test it for the original. Come up here. 1 plus 8 is 9. Square root of 9 is 3. 3 times 2 is 6. 6 plus 5 is 11. And then you have a -1. And then that doesn't work. Whereas you put in -7, -7 plus 8 is 1. Square root of 1 is 1. Times 2 is 2. Plus 5 is 7. And then a double negative is equal to positive. So this one works. This one doesn't. So you throw it out. So you have to check your answers. Otherwise, you will get this wrong. All right, so answer is -7. Now, we're solving for an absolute value equation. We have to get this by itself, this absolute value, we have to get it by itself. So we're going to go ahead and subtract 3 from both sides. And then we're going to divide both sides by 3. And then we're going to set the contents of the absolute value equal to the other side, as well as set the contents of the absolute value equal to the opposite of the other side. Now we go ahead and solve them individually. We'd add 4 to both sides, we would get 6. And then 6 divided by 7 gives us 6/7. As one answer. And then we do the same thing here. Add 4 to both sides, we get 2. 2 divided by 7 is 2/7. And so be it. That is our answer. Now, we can go ahead and check our answers if we so desire. That's your choice. All right. I knew it was going to work. And so I went ahead and just did it. But you're probably thinking, well, how did you know it worked? It's only when I get radical positional values. Like if I have the absolute value of a -2, I know no matter what answer I come up with, it wouldn't work. So I would stop right away and put DNE. See, things like that is when I know the solution we come up with through the process will work. As long as I and I've warned you about that in previous, recordings. All right, now 32. Now, go ahead and subtract 4 from both sides. Divide both sides by 4. You have negative the square root of, or excuse me, the absolute value of negative 8x plus 4 equals negative 5. Then now evaluate this. There is no such number that when you take the absolute value of it, it will give you a negative number. Right? What does negative, or what is absolute value? It's the distance you are away from 0. You can't be negative 5 away from 0. You can only be 5 units away from 0. So that's why this answer is CNE, does not exist. All right, that's using common sense. Very powerful thing to use in math. $36. Now these are compound inequalities. Now when you have this, what you do to the middle, you do to both sides. So if I'm adding 4 to the inside here, so I can get rid of the absolute value, or excuse me, get this by itself, excuse me, the variable by itself, I'm going to do it to both sides. So I'm going to add 4 to everything. Adding 4 to this makes it 0. Adding 4 to 8 gives us 12. Now I'm going to divide everything by 2. And now we're going to be between, okay, between these two values. Now, this one's going to be in closed circle, and this one's going to be an open circle. All right, and so it is that we have that. Now, I believe, you should remember that a closed circle is a bracket, and open circle is parentheses. So in interval notation, the symbolization is that. Now, in some resources, they take and do away with circles or open and closed circles and just put brackets and parentheses for those values. Okay, which is good. Okay, so we have that. By the way, let's go ahead and show the answer for that. All right, now the final and last question that we're going to look at is question number 38. Now 38, whenever you have a less than symbol, it is in your better interest to simply go ahead and take the opposite of the other side and put a less than or equal to sign there, and then put 2x plus or minus 8, and then put a less than or equal to the positive version of 14. So this is a compound inequality. Just like we did with this problem, we do the same for this. We're going to go ahead and add 8 to both sides. Adding 8 to both sides. All right. And then go ahead and divide all things by 2. And here we have our answer. All right, so we would just go ahead and put bracket -3, 11, and then go ahead and answer it. All right, and then of course there would be closed circles at both those values. All right, and that is basically in a nutshell what you need to concentrate on for your test 1 for chapter 2. All right, good luck with your studies, and I'll be posting this. Thank you.